Okay, 11.5 notes. Before we get to that, we will do a little bit of review. Looking at this, the question is, does it have a sum? So if you notice, summation notation, that tells us this is a series, and the fact that the lower limit is 1 to infinity is telling that it's an infinite series. And by looking at the rules, it looks as if it's in the form of a sub n is equal to a1 times r to the n minus 1, telling us that it is geometric. Now, if you remember, in order to have a sum of an infinite geometric series, the ratio had to be between -1 and 1. So looking at these two, we're looking at the ratio and looking at them. 1 on the left tells me no, because that common ratio is greater than 1. And looking at the other one, the ratio is 1/6, meaning that is between -1 and 1, meaning we can find the sum. So let's go ahead and let's find that sum. If you remember, the sum is equal to a1 over 1 minus r, which in this case, the first term is -4, common ratio of 1/6, so -4 over 5/6, which is telling me -4 times 6/5, or -24/5. That is the sum of that infinite geometric series. Just a little review from the last section. So today, 11.5, and we're going to be talking about what are called recursive rules. Okay. Now, what a recursive, we've learned about explicit rules. That's the a sub n is equal to dn plus a sub 0, or a sub n is equal to a sub 1 times r to the n minus 1. First one being arithmetic. Second one being geometric. So again, those are explicit rules. Today we're going to talk about recursive rules. Now, a recursive rule builds off the previous term. So if we were to have a recursive rule that builds off something previously, we have to start with a term. So the one big thing to remember with a recursive rule is that you are going to have to define your first term, and then from there we're going to have a sub n is equal to a sub n minus 1. Now think about it, a sub n minus 1, if you're taking that n, subtracting 1, a sub n minus 1 is referring to the previous term. So then the next part, if it's arithmetic, you're going to add that common difference, or you're going to have a sub n is equal to a sub n minus 1, which again referring to the previous term, times that common ratio. But again, you will always have to define a sub 1. So, first off, just given a recursive rule, let's write the first 5 terms. So again, a sub 1 is defined. So we're given that one. So that is 1. Now a sub 2 is saying we're going to take that previous term of 1 and then square it, plus 1. Okay, so that's saying 1 plus 1, or 2. And again, a sub n minus 1, that's talking the previous term. So in parentheses, we're taking the previous term that we got, which was 2. So we got 2 squared plus 1, or 4 plus 1, to give us 5. And again, there's our a sub n minus 1, referring to the previous term, which we will put in place there. So 5 squared plus 1, or 25 plus 1, to get us 26. So then 26 squared plus 1 which will give us 677. So again, a recursive rule building off that previous term. So to start, we're putting that last term that we got in place of a sub n minus 1 to help us find that next term. So just a little more practice. Again, a sub 1 is defined. So we got -2. And then a sub n minus 1, so putting the previous term in place of that, let's say -2 minus 10, or -12. Okay, so then using that term again, -12 minus 10, -22. -22 minus 10, -32. -32 minus 10, -42. And again, if you notice that the common difference, this is arithmetic, our common difference is -10. So just get to that next term, you're just subtracting 10. Okay, again here, that first term is defined, so we got -2. And if you can tell, this is the ratio times, since we're multiplying, so we have a common ratio of -3. So then in this case, it's saying -3 times -2, which gives us 6. So then -3 times 6, -18. -3 times that previous term, -18, 54. And then again, finally, -3 times 54 to give us -162. So again, recursive rules building off that previous term. So in this case, you are multiplying that previous term by -3. In this case, you were subtracting 10 from that previous term. So if you look, -2 minus 10, get -12, -12 minus 10, -22, so on and so forth. So writing these recursive rules, biggest thing, write your first term. So if we look, write a recursive rule for the arithmetic sequence where A1 is 15. So you need to define that. Even if I just say that, you still need to define it. And the second part, a sub n is equal to a sub n minus 1. And since it is a common difference, that means it is arithmetic. And if the common difference is 5, that means you're adding 5 to get to the next term. So we take the previous term plus 5. And that's it. Okay. So again, define A1. Give me that a sub n is equal to a sub n minus 1. In this case, plus the common difference, because we always add a common difference. So plus 5. On the next one, write a recursive rule for the geometric, meaning we are multiplying. And again, define a sub 1, which is 4. And then when we go to the next one, it's always a sub n minus 1. It's just a matter if we are adding or subtracting or multiplying or dividing. In this case, since it's geometric, we are multiplying. So a sub n minus 1 times that common ratio of 0.2. And again, you can put that 0.2 in front and say 0.2 times a sub n minus 1. Does not matter, just as long as I'm seeing multiplication, since it is a common ratio and it is geometric. Okay, write a recursive rule for the sequence. So again, now it's just giving you the actual sequence. Does not change. You are still able to find that first term of 66. And then you need to figure out your pattern now. How would I get from 66 to 33? And it is a matter of dividing by 2. Divide by 2. And again, when you're dividing by 2, it's the same as multiplying by 1/2. So our common ratio in this case is 1/2. So a sub n is equal to a sub n minus 1 times 1/2. So again, it is geometric. Therefore, we are multiplying, so that previous term times that common ratio. Okay, a little bit of a challenge problem. It's not arithmetic or geometric, because plus 1 does not work. Times 2 times 2 times 2 works up until you hit that 10. This is a case where the only way you're going to be able to write a rule for this is with recursive rules. Okay, so it's kind of a tough one to see. You start with the first two terms, you multiply them, and then add 2. So 1 times 2, you get 2 plus 2. That's how they get 4. Okay, so then you take, for 10, 2 times 4, that's 8, plus 2 is 10. Okay, so it's worked up to this point. And on the next one, 4 times 10, 40, plus 2, you get 42. So what we're doing is we're taking the previous two terms, multiplying them, and then adding 2. So this is a case where you have to define both A1 and A2. Since you are multiplying two terms, you need to define two terms. And the way we're going to represent this, A sub n is equal to A sub n minus 1 times A sub n minus 2 plus 2. This isn't one I'm going to expect you to know right off the top of your head. It's more of a challenge problem. Again, multiplying two previous terms and then adding 2 to that product. That's recursive rules for 11.5. Your homework assignment is 11.5 under Chapter 11 homework. Make sure you do that. If you have any questions, make sure you are asking. Have a good day.